Casper. Casper is doing homework and Marthox comes and takes the calculator away from him. Oh no!
Hey, give me back my calculator.
No way. I will give you clues to find your calculator.
Oh man, what kind of clues?
Equations on how to find limits, and you must solve them correctly if you want to find your precious calculator. When you find the answer, take that many steps north of the barbed wire.
But I don't know how to solve it without my calculator. I guess I'll go to my math teacher for help. Mr. Bobs, Mr. Bobs! I lost my calculator. I need it in order to solve these problems.
What type of equations will you be solving?
Limits.
Okay. What's a limit?
I don't know.
Geesh. A limit is a behavior of a function as it approaches a point. Think of it as a specific point that a graph reaches from both the left and the right.
Stop.
Here, I'll show you an example of how to find a limit. In this example, it asks, what is the limit of this function as x approaches 2? The best way to solve this is to plug in 2 for x. So you put 2 plus 5 over 2 squared plus 1, which equals 7 over 5. And that will be the limit as x approaches 2 of this function.
Okay, but what if you get a 0 in the denominator? Then what happens?
Then you will need to simplify the function before you can plug in the number. I will show you an example. This is asking what is the limit of the function as x approaches negative 2. Here, if you plug in negative 2, you will get the denominator 0. Therefore, you cannot have that approach. Therefore, we will simplify this function further before we can plug in. This is just a rewrite of the function. X squared plus 3x plus 2 simplifies to x plus 1 times x plus 2. Here you see that x plus 2 over x plus 2 cancels out, and then you have 1 over x plus 1. Here you can plug in negative 2 in this equation, then you will have 1 over negative 2 plus 1, which is 1 over negative 1, which is negative 1. This will be your limit.
But what if there's a really big ugly function? Is there something else I can do?
Yes, you can use L'Hopital's rule. It states that when finding a limit, you can simplify or rewrite the function by finding the first derivative of the top over the first derivative of the bottom. For example, this is asking to find the limit as x approaches 0 of 4x minus sine 4x over x squared. First, you can take the first derivative of the numerator over the first derivative of the denominator, which will be 4 minus 4 sine 4x over 2x. Here you cannot plug in 0 because if you plug in 0 into here, you will get a 0 in the denominator. Therefore, you can use the L'Hopital's rule again to simplify further. When you take the second derivative, it will be 16 cosine 4x over 2. Here you can plug in 0, and when you plug in 0, it will equal 16 times cosine of 4 times 0 over 2, which will equal 8, and that will be your limit.
Okay, now I can solve the equation that Marthox gave me in order to locate my calculator.
Okay, so this is asking for the limit as x approaches infinity of this function. Here we will use something different because it's infinity and not a number. Because in this equation the powers have the same degree, we will use the coefficients as the limit. So here you just rewrite 5x cubed over negative x cubed.
So the limit is 5 over negative 1, right?
Yes, it'll be 5 over
Or
negative
negative 5.
1, which equals negative 5.
So the calculator is located 5 steps north of this barbed wire. Yay!
Casper and his tutor get to the point. Then they find the locked box.
Haha, you thought it would be that easy, did you? In order to unlock this lock, you must prove to me that this function is continuous.
Oh no! How do I prove a function is continuous? Mr. Bob, help me!
Okay. To prove a function is continuous, you must show that the limit from the left and the limit from the right are equal, and that the function is defined at that same point. Here is a piecewise function. This is the function from the left. This is the function where x is defined at the point 2. This is the function where x is greater than 2. You must plug in 2 for each of these equations, and if they are all the same value, then they are continuous. If they are not the same value, then it is not continuous. Here, we plugged in 2 for each of these equations, and they're all equal to 1. Therefore, this function is continuous.
Yay! I proved this is continuous! Now I have my calculator! Thank you, Mr. Bobs!
You're welcome.
Darn, you were smarter than I thought you were. But now you have mastered limits.
Yay!
If you get a 0 in the denominator, you would have to simplify the function even further. If you get a 0 in the denominator, you would have to simplify the function even further before you can plug in the value. I'll show you an example.
I'm holding my teeth, you don't understand! Alright, next one.
Okay, next